Okay, so here's a problem. Multiple mass incline. I want you guys to go ahead and try deriving the acceleration of the system on your own. This is probably as hard of a problem you will encounter for Newton's second law when there's objects accelerating. So you'll have three separate free body diagrams. You'll notice that the incline does have a coefficient of friction. So I want you guys to go ahead and pause the video now and try to solve for the acceleration on your own. Okay, so the first step is to draw a free body diagram for each object. So let's go ahead and start with M1. It's the simplest. So here's M1. We have two forces acting on M1. We have force due to gravity pulling it down, M1G, and tension 1 pulling it up. Okay. For M2, we have, it's connected to the same string. It's the same string connecting M1 and M2, so we have tension 1 pulling on the box this way. And we have tension 2, there's another string connected to it on this side, tension 2 pulling down this way. And we're going to assume that the system is going to move clockwise, so that means this is the positive direction. So if M2 is moving to the right, that means force of friction must be opposing that motion to the left. Force of friction 2. And then he's got an up force, normal force, and straight down force of gravity. That's M2G. That means we have components. We have a Y component and an X component. So here's our theta. And I'll write those in a different color so you can see them. So the Y component is M2G cos theta. And the X component is M2G sine theta. And our third object is M3, and it's a little bit further down the incline. So we once again have tension pulling up on it to the right. This time it's the second string, so it's T2. And since it's going to be moving up the ramp, its force of friction is down the ramp, F of friction 3. And its normal force is perpendicular at the surface, Fn3. Let me specify number 2 as Fn2. And there's only one more force, and that's gravity, Fg2, pulling down. That means it's got a Y component and an X component. At this point, if you go directly to the components to start solving, that's fine. It's where you should be, what you should be doing. So we have M3G cos theta, Y is the Y component, and the X component is M3G sine theta. Okay, so if you got this far, that's a huge step. The next step is what I hope that you can accomplish on your own after watching this video if you were to do the problem by yourself again. So we're going to have a few different equations going on. We'll have one for block 1, 2, and 3. So let's go block 1. And then let's go block 2 right here. Let's do those two first. So for block 1, this one's pretty simple. We have sum of the forces, and there is only the Y direction, so we only have one equation. Sum of the forces on 1 are equal to, since we said clockwise is positive, that means M1G is positive. M1G minus tension equals M1A. For block 2, we have sum of the forces is equal to, well, we have tension pulling up the ramp, so that's going to be positive, T1. Down the ramp is T2, and force of friction, so those are negative, negative T2. And we also have, let's not forget the component of gravity here, the X component, M2G sine theta. Also negative. Okay, and let's go ahead and do block 3. So some of the forces are, well, T2 is pulling up the ramp, so that's positive. And we have force of friction pulling down the ramp, so that's negative. And, oops, I called that force of gravity 2, that's actually 3. And then we have the force due to gravity. The x component is pulling down the ramp also, so minus m3g sine theta is equal to m3a. Okay, so if you get this far, these are the three equations of the system. This is typically how far the AP test may ask you to derive, but you should be able to solve for the acceleration. So let's, since this is an AP class, let's go ahead and do that. So let's go ahead and solve for tension first up here in block 1. So if we add T on both sides and then subtract M1A over, you can do that simple math. You get T is equal to M1G minus M1A. Basically, we want to get rid of these T1s and T2s. So we're going to plug this T1 into our equation in block 2 for T1. And we get M1G minus M1A minus T2 minus force of friction 2 minus M2G sine theta equals M2A. So we can do the same thing for our block 3 and solve for T2. So let's solve for T2. We get T2 equals M3A plus force of friction plus M3G sine theta. Okay. Now you'll notice that there are these frictions going on here. So let's go ahead and substitute those right now. Force of friction 2 and force of friction 3. Well, we know that force of friction 2 is equal to mu times Fn2. Well, let's just avoid the step where we have to write the equation, the y equation for our second object. Fn2 we can clearly see is equal to m2g cosine theta, okay? There's no acceleration in this up and downward direction right here on the incline. So Fn2 is therefore equal to m2g cosine theta. Same for the force of friction for 3. It's equal to m3g cosine theta. And let's go ahead and substitute those back into the equations. So we get m1g minus our force of friction 2 yes, it's a lot of algebra, but it's not very difficult algebra. You can do it. So let's take force of friction 3, substitute that one in. We get T2 equals M3A plus mu M3G cos theta plus M3G sine theta. Okay, so now we have T2. Let's go ahead and plug that T2 in right here. Okay, we're almost there. We're down to having just M's, mu's, G's, and thetas. So M1G minus M1A minus, so since we're subtracting T2, we want to make sure there's a negative in front of each of these factors. So M3A minus mu M3G cos theta minus M3G sine theta. So that's all T2. Now we have to continue the original equation, and I will continue it on this line right here. So I'll just write it further down. Minus, we left off right here, mu M2G cos theta minus M2G sine theta equals M2A. So the next thing you'll notice, like the problem with the modified Atwood machine, is that there are 3 factors that have A. We have an M3A, we have an M1A, and we have an M2A. So we want to get all those A's on one side of the equation. So if you didn't notice, this was my equation. And now we just need to solve for A. So I'm just going to rewrite our equation up here one more time. We had M1G I'm just copying this green box so I can use it again. Okay, now that we have our equation, there it was. That was what was inside the green box. So we want these A's by themselves. So here's an A, here's an A, and an A. So let's add over our M1A. This is our left-hand side of the equation. I know it's all kind of cramped together. And here's our right-hand side on the other side of the equal sign. So let's add over our M1A and add over our M3A. And we get, on our right-hand side of our equation, we have, so I'll write it one more time. We have M1G left on our left-hand side. Then we have a minus mu M3G cos theta minus M3G sine 3G sine theta minus mu M2G cos theta minus M2G sine theta. That's all on our left-hand side. That's now going to be equal to M1A plus M2A plus M3A. And let's go ahead and pull out an A on both sides of the right-hand equation. And we get A multiplied by M1 plus M2 plus M3. So I'll just rewrite the right-hand side. I won't rewrite the left. So the left-hand side is not, here's the left-hand side of the equation. I'll specify. There it is. Left-hand side. Here's the right-hand side of the equation. So our right-hand side is the only one that's changing. So we can rewrite our final answer. And you want to make sure you divide over M1 plus M2 plus M3 on both sides. And we get A is going to be equal to everything on this left-hand side divided by M1 plus M2 plus M3. So I'll rewrite that if I have room. Let's go ahead and put it right down here. A is equal to M1G minus mu M3G cos theta minus M3G sine theta minus mu M2G cos theta minus M2G sine theta all over M1 plus M2 plus M3. So you could see how the AP test could make this a simpler problem. For example, by making it so the system doesn't accelerate, it actually has a constant velocity. Okay, that would make it a much simpler problem. Or even taking away friction, making it a frictionless system. Okay, so if you did this all on your own, you're awesome. You're ready for anything for this Newton's second law.